That's the problem one. Should we have some Q&A section here? Of let's first go through all the problem.
Yeah, because I don't have any question from the YouTube live, or if some participants in Zoom, welcome to unmute yourself, because we have not so many people. And Xiting can answer some question if you have any in the problem one.
Yeah, feel free to ask any questions. And if not, then I just goes to the problem 2. And problem 2, I think, is the easiest problem in this contest. And this problem give you n intervals L and Ri, and n integers Ki. And it's has limitation that Ki is less than or equals to I minus Li plus 1. And Ki is greater than 1, I think. And for each I, you need to compute the number of j not equals to I, such that the interval j and interval I overlap with length at least ki. So how to solve this problem? You just need to detailedly talk about all the conditions. And there are many ways to talk about each conditions, but here I just introduce one. That is, for each interval L, R, and it has a limitation of k. Let's consider if another interval AB can contribute to its answer. And there are 4 different conditions. And the first condition is that if A is at the left of the interval and B is at the right of the interval, then this means that LR is totally included in AB. So this times AB always contribute to the answer. And the second case is A is less than L and B is in the interval. So in this case, AB contribute to the answer when B is greater than L plus K. And third condition is that AB is at here. And now AB contribute to the answer when A is less than or equals to R minus K. And the last condition is that AB is totally inside LR. And AB contribute to the answer when B minus A is greater than K. And if we sum them up, then if we define the count to count the number of intervals that satisfy the limitation of the L positions is in the first part and R positions is in second part, then we can write down the formula of answer equals to calculate 1 dot L R to infinity, or calc 1 dot L plus K to R minus 1, and like this. Okay, and there are 2 problems remain. The first problem is how to implement calc, and the second problem is how to calculate part 4. So first, how to implement calc. Generally, we need to calc A to B, that is L. The L bound is in the A to B, and the R bound is in C to D. And if we want to calculate this, we can use we can first translate these into 4 parts. And now we change the problem into calculate 1 to B and 1 to D. And to do this, we can sort all the intervals by B and add them one by one at position D. When an interval is added, we update its answer by CNT1 to D, the sum of CNT1 to D. And this can be done in segment tree or BIT, anything you can use. You can use anything to do this. And the time complexity is n log. And the hard part 2 is how to calculating the part 4. And remember that part 4 is the number of the interval that is totally contained in the AB, and its length is greater than K. Okay, so let's denote the length to be B minus A, or this is the length of the second interval, and part 4 equals to the length. First, the length should be less than okay. This is a little bit dirty coding work. So the first, we count the number of the interval that it has length less than R minus L. And then we minus it by the number of the interval with length less than K. Now we have all the intervals with length from K to R minus L. And then we minus it by the interval with left positions less than or equals to L, because we only want to count the number of the intervals that is totally inside the L and R. So we first minus the left position less than L, then we minus the positions with B greater than R. Same reason. And now let's look at which intervals are minus too much, are minus mistakenly. We find out that if the left position is less than L and the length is less than K, then we accidentally minus it one more time. So we add them back. So now the part 4 turned into a long formula like this. And each CNT problem is the same as to calculate each CNT is the same as to calculate our things like here. If we review B and length to be the two things that first have a bound and the second has another bound. They are the same. And then the total time complexity remains n log. And also, if you are familiar with the data structures, you can brute forcefully doing this calculation. Brute forcefully calculate this in n log square solutions using the maybe tree maybe the 2-dimension segment tree. But they are slow and also hard to implement. So I think the best solution to pass this problem is still detailedly talking about all the conditions.